Right. Okay. This is the continuation of the previous session. So we were discussing object-oriented analysis. We were discussing basically what's objects, the representation of objects, and also like the instances with the respective values. So this is also like one way to model, and we will be using this in object-oriented analysis. Right. Having said that, we were discussing parent objects, the child objects, and the child objects we call it inherits the attributes from the parent objects. For example, in this particular case, we have name, age, sex, and hair color. So we will have the same, plus you can actually have additional attributes as well as methods for child. Right. Now, we were discussing the details of the objects. And various objects, you have a different set of attributes and different set of methods and so on. Right. When it comes to methods, you know that it'll define for a particular task which object can perform, and you can have set of objects as well, right? So these are the things that we were discussing. And object interactions happens through the messages. So for that, we can what to do, for example, in message tells the object to perform certain method, right? Okay. So then we were also discussing a couple of ideas. For example, when we have the message, same message, the different objects can behave differently, right? So depend on good night, for example, the message, different objects, parent, dog, and child, for example, may cause different actions. So that means it's different meanings for different objects. And this is called polymorphism. And then we were discussing like to create the objects, we started with the classes, which means the objects belongs to the group or category, what we call the classes. So if the objects are from the same class, which means you have a set of common attributes as well as common methods. Right. So for example, here we will have vehicle class, and then we have set of subclasses, right? Which actually can inherit the attributes and the methods from the vehicle class. So you will see different, subclasses may contain some additional attributes, which we here represent as uncommon attributes. Okay. So some cases you can have more generalization for a class. We call superclasses. Now, for example, if you take the class as employee, the subclass could be the instructor. And for example, if you generalize more, then the superclass, we call it, could be the person. Right. And then we were looking at the relationships of objects and classes, how they perform different business functions and transactions for the system. So when we are going to create the objects, the classes, and the interactions, so these relations matter. Right. Now, for example, getting the common attributes coming from the parent to child, we call it inheritance, which means when you define a child from parent class as a subclass, we will say it inherits all the attributes as well as the method. So in this one, you will see in child inherits all the attributes from the parent, and methods also, all the methods in the parent class is inherited by the child. So these two ideas that we have discussed so far now, polymorphism and the inheritance, right? Now, once you identify objects, the classes and their relationships, then we will create what we call object relationship diagram. So that can actually provide the overview for the system. Right now, for example, in this particular case, you can see the employee is a class, and then we have a set of subclasses based on that. The manager, office staff, and the instructor. So manager is a employee, and office staff is also an employee, and instructor is also an employee. Right. And then there are different, interactions are there. So for example, we have a registration record, which comes from different, employees. So for example, office staff can administrates the registration record. And also like instructor, for example, he or she indicates the availability. And this is for actually a fitness class. So we have a fitness class, and some students may take the fitness class. So instructors will teach the fitness class. And then registration record will generate the roster for the class. For the different students, they will have a different roster. And that registration record also adds the students, right? At the same time, you can see here as well, the manager determines the fitness class schedule, and then this will open the fitness classes with the registration record. So as you can see, this is called object relationship diagram, where we will show the objects, so superclasses and subclasses, and then how these objects interact with the other objects. So everything is represented here, what you see here. So in these is objects, right? Now, UML is what we normally use or commonly use to, represent, objects interaction or object relationship diagrams. And these ones consist of use cases, use case diagram, class diagrams, sequence diagram, and state transition diagrams, and finally activity diagrams. So what we are going to discuss it here is these different, representations, where it will capture different aspects of the modeling. Now, for example, when we have use case modeling, which we call use case diagram, it will actually show you the what we call the dynamic or we call behavior diagram, right? So the use case, what it does, it describes the business situation. So there'll be actors. Now, for example, here we have the patients making an appointment, and the patient is the actor or a person who interact with the system. And the make an appointment is a function that we can call it as a use case, right? So, so each use case will represent some kind of a scenario, which means it could be some kind of action, service, or some kind of a, function. And the use case also represents some steps as well. Now, for example, after making an appointment, what happens? So you can have, set of steps, and you can also have, different, actions within this, right? So actors usually we call external entities, and the other ones, or the actors, is the ones actually initiate the user case, right? So what happens is the actor will initiate the user case to perform particular function or process. So in this particular case, we talk about, okay, patient is initiating, make an appointment, that particular task. Now, in this particular case, what you see is several actors with several use cases, right? The first one, you see the passenger, and the task is, the use case here is making an airline reservation. So some diagrams you might see that this particular task is inside this one, but I'm using the books representation, which actually in their representation, this is from outside. So you can stick on, if you're already familiar with these concepts. So if you are already familiar with some other notation, you can also prefer to use it. There's no fixed set of rules that you should use this one. But in this particular case, the user case actually the represent outside the oval here. The second one, you will see the customer placing an order. And the third one is bus dispatcher change pickup address. Right. Now, when it comes to relationships with actors and user cases, we represent using a line. So we can see the relationship we indicate with the line. And then these relationships can also be used with users, includes, or extends, right? And this first one, users or include, indicates that it's needed by another in order to perform the task. And the extend, it's indicated there are alternative options. So we will have an example, we'll look into that. And the UML indicates the relationship, the arrow at that point at the user case being used. So that's why we have an arrow here. So the passenger is using the user case here, make airline reservation. Now, the two things, for example, we have the first one, we have a student, that is the external entity, the actor, and the user case is adding the fitness classes. And to produce the fitness class roster, it will use the use case add fitness class use case. Now, similarly, instructor also indicates another use case called change availability. And then the update instruct information use case, which uses the change availability use case. So you will see student adds a fitness class and produce what we call fitness class roster, which uses the results of, add fitness class to generate the new fitness class roster. Similarly, the second one, we have an instructor changes his or her availability. This could be like sometimes, that some instructor might say, okay, in Sundays, I'll be available during the morning and so on. So depend on that, we are going to update the instructor information, and then that can, use the change availability use case to indicate the updating instructor information. Right. Now, let's look at how to create use cases. We call it use case description. So to create a use case, you have to, first of all, look at the information you gather during the requirements modeling. So we will first of all create, collect all the requirements that you need to represent the system. And those information, we will use it to create user cases, right? The objective of this is to identify actors and their functions, right? I told you the functions could be the use case. And for each, you develop what we call the use case description. So this is like a table, right? Now, for example, this user case add new student, right? So here is the information. We have name. That name for this use case is add new student. And the actors interact with this is either students and the managers. And what happens here basically describe the process used to add students to the fitness class. And sometimes this might be a success, sometimes this might be a failure, there could be like alternative actions. So if it is success, then we will iterate like what happens, right? For example, how manager. So if the new student, adding a new student is a success, then manager checks the class schedule, right? And also manager then notify the the students, the availability of the fitness class. And then third one is fitness class is open and students can pay the fee, and then only, manager registers a student, right? Now, the other alternative one is like there's no space for a student to, for particular fitness class schedule. So in that particular case, the outcome would be like fitness class is full, and then manager can notify the students, right? Preconditions, that means to happen this user case, the preconditions, student requests the fitness class, and after that, meaning like post condition, students is enrolled in the fitness class and fees have been paid, right? And then you can also list any assumptions you have. Right. Now, to create user case diagram, that means the summary of all the related user case within the system, or this could be done for a subsystem. So first thing is you have to identify the environment, which means the boundary of the system. Now, usually this representation is a rectangle. Then you place user case on the diagram. Usual representation is oval within this rectangle. And then you add the actors, right? So sometimes there could be actors or there could be some other systems. Now, for example, let's assume that, okay, a person is using an ATM machine. So in ATM machine, let's say a person is checking the his or her bank balance. So in that particular case, to check whether the enough funds available, you have to, use some other systems, right? So the other systems also we represent as the, actors, like the stick figure. That means like the shape that you have seen earlier. And then you show the relationships. Now, here is an example for auto service department when you want to like service, let's say, automobile. So customer can request the service, right? And then we need to create work order. And the person who involves this is the service writer who writes the work order. Well, now, once you create the work order, it should update the work schedule and it should notify the mechanics to perform the work, right? So once, the work schedule is notified to the mechanic, and when the mechanic performs the work, so we need to prepare the invoice. So the class using the work order, we need to prepare the invoice, and finally service writer will checks the invoice. So you can see here, so to draw this one, first thing is you first identify the boundary, which means the rectangle shape, and then you will have all the use cases. In this particular case, we have three use cases: create work order, update work schedule, and prepare invoice. And then we need to identify the actors in stick figures: customer, service writer, and mechanic. Finally, the relationship. So that's how the order should be when you're drawing the user case diagram. Now, another example, creating a bus route. So again, as I told you, you first start looking at the rectangle shape, which separate the environment, and you indicate the system. Within the system, here we have three use cases: create requirement forecast, prepare route plan, and develop staffing plan. And in this particular case, we have three actors: student, driver, dispatcher. And the user case starts with the student. Student initiate the create requirement forecast, and which will notify the dispatcher. And then dispatcher determines the preparation of the route plan, and it'll develop the staffing plan. And the dispatcher is the one who actually, create this the staffing plan. So that finally notifies the driver to, for the drive. Right. Here are like some of other, diagrams. Now these are like from additionally I have taken from few sources just to give you some idea where like how you may develop user cases in different releases or different steps. Now, in this particular case, student and looking at class registration. Now, you can see there are 4 use cases here. Starts with viewing user schedule, class schedule, add class, drop class, view my classes, and so on. So these are the 4 in the first release. That means initially you create only those 4. Right, and this case you can see student is actually starts with the within the class schedule and adding the classes, but students to drop a class, you have to get the registrar or the system to involve in this one, because the student itself, you may not, drop any classes. Now, in the release 2, you can see here, there's a one additional, in this particular case, obtain help, where we have operators also involved, right? That's the release 3. The third one, there will be another one where we have the time and you have a pay fee user case, and school account is the other actor in this particular case. So this is to just show you like in some cases you are developing user cases in different steps, different releases, not in a one single shot, right? And here is another one from another book. You can see like different, notations for use, which has like 2 extensions. That means you can see some user cases are included, some actually extends. So we discussed these 2 earlier, which in this particular case, for example, you can see make new customer offer. You have to have the created new customer, then only you make the customer offer, and then make customer offer, you will have update customer information. So the include and exclude also could be a part of use case diagrams. Right, now let's look at the class diagrams. Now in class diagrams, what we have is object classes and relationships in the user case. So first of all, to create a class diagram, we have to review the user cases and to identify the underlying business processes. So in class diagram, usual representation is we use rectangles to represent classes, and then we will have class name, and then class attributes and the method, which actually what we have seen earlier. Then we can draw arrows to represent the relationships. If there are a relationship between, like, let's say 2 classes, you can draw a line to connect those 2 classes. And then you can place labels, right? So what kind of, action which relates the 2 classes. And then last one, we will have how the instance of one class related to instance of another by specifying cardinality, which means like whether it's a one-to-one relationships, one-to-many, or many-to-many, and so on. Right. Now, cardinally, there are different representation. For example, we will also discuss in databases these relationships when we have like, the tables. So in UML notation, usually we will have 0 to many, which indicates 0 with 2 dots and then the asterisk, which indicates the 0 many. That is maximum currently we call. Maximum means the maximum participation for the relationship, right? So that means, for example, in the first one, we have employee and payroll deductions. Sometimes you have deduction, but it's not compulsory. So that's why we have 0 or many is there. Similarly, you can have 0 and 1. Now, for example, if you have employee and a spouse, so some employees may not have spouses, right? Maximum you can have one spouse. Okay, so that's why here the representation 0 and 1. 1 to 1, I think is common. Usually, if you have exactly one manager interacts with the one sales office, so we can represent it as 1 to 1 relationship. Then you can have 1 to many. Again, this is compulsory, sometimes we call it. So the order consists of the items ordered, and item ordered you will have, right, belongs to one order, right? So these are the representation we will see in the relationships. Now here is one example where how the class diagrams, all the classes are identified. So in this particular case, we have class sales manager, sales office, sales representative, customer, order, and items. And then the lines indicate that, okay, sales manager managing the sales representatives. So sales managers may, have sales representative, which means some sales manager might not have managing any sales representative, and some managers may manage more than one sales representative. Now, similarly, the other way around is like it's one sales representative, you have to have a sales manager, right? Similarly, if you look at two classes here, sales manager and sales office, you can say again, sales manager managing a sales office and sales office managed by a sales manager, again, one-to-one relationship. And then sales office and sales representatives, sales representative have 0 or more sales representatives, but when you have sales representative, you have to have a sales office. Similarly, if you look at the customer and sales representatives, so you can see for a sales representative, you may assign to 0 or more customers, but when it comes to customers, you have to have a sales representative. Similarly, customer places orders and customer may place 0 or more orders. That means there could be some customers in the system without placing any orders. An order contains multiple items. So that means in an order, you will have one or more items. And items may belong to 0 or more, right? That means there could be some, items may not belong to any of the orders. So this is how we can represent the class diagrams. A slightly different one, you may have seen this in database courses. So this representation is actually coming from the popular fundamental of database systems by Elma Srinawate. In that particular case, it represents a company. So in a company, according to there, we have employees, we have departments, and employees work for departments. So you can see here, their notation is actually slightly different from what we have just discussed earlier, but most of them are the same. Now, for example, employee can work for a department. The minimum is also 1, maximum is also 1. In UML notation, you can just put 1. And if you take a department, it says you have to have at least 4 employees or more, right? So there's a minimum condition, right? So we can say 1 or more if you relate it to what we have seen earlier. Similarly, an employee can manage a department. So you can see here, employee may work as managers in the department. So the maximum one person can be. But the department side, you have to have a manager. So that's why it's 1 to 1, or you can say 1. Right. Similarly, I will talk about another one. For example, if you take employees can work on different projects. So that means employee can work for 1 or more projects. And if you take project, you can have 1 or more employees. So this is another representation for a class diagram. As you can see, since it also, most of the things that we have seen earlier is very similar, but there are some exceptions with the representation. Right. Here is another one. Now in this one, we have like the banking system. So we have a bank head office, then bank branch, then bank accounts, the transactions, the customers, and the two types of accounts. So you can see the subclasses here, the bank account, there are two subclasses, the current account and savings account, which may inherits already available attributes and methods from the bank account. But then that is the new additions, what you have seen from the earlier. Other than that, you will have the same cardinality representation. For example, if I take bank account with the customer, you can see bank account should have at least one or maximum one customer, but the customer can have one or more bank accounts, right? Similarly, if you look at head office and branches, the branches are belongs to a one head office, but a head office can have more than one or more branches. So this is another simple representation for the class diagram. Here is another one from another book. So this actually representation is coming from System Analysis and Design by Dennis and Wixom and Roth. In that particular case also, you can see similar representations. Now, for example, if you take employee, there are two subclasses we can identify: shop mechanic and salesperson. And the more generalized superclass is person, and then you have two subclasses based on the person as employee and customers. And you can see some subclasses have a representation. Now customers have offers, so customer makes an offer. For example, you can have one or more, but if you take an offer, it belongs to only one class. Right. So now we discuss or finish discussing two types of diagram. The first one is user case diagram. The second one is the class diagram. Third one, how exactly this interaction happens within the time, we can represent using sequence diagram. So we can call it a dynamic model of user cases. We can also show interactions, and then there are vertical bars which indicates that when this interaction happens. Now, for example, in this one, we have two classes, and then this dash line we call as lifelines. And then among this, you will have message passing. So for example, in this one, the message one is passed from class 1 to class 2, and then there will be another message passed from class 2 to class 1, right? So during this period, these interactions happen. So this is the first one to start with. So it will start, and then this, vertical bar actually represent at the end. And finally, this cross indicates the end of the interaction, right? So that what it means is class 2, there are no interactions after this. Right, in sequence diagrams, we can have a couple of things. In sequence diagram, we represent classes as rectangles. Then there are lifelines. Usually we use them as dash lines. Then there are some message passed among the classes. And then you will have arrows which indicates the direction, right? And finally, focus, it's actually what happens or what it covers during the lifeline, right? Now, for example, focus could be like you have send or receive information, which means the interaction you can represent with the focus. Right, now here are like a couple of things. Remember, we discussed fitness class example. So if we are representing the dynamic behavior of the user case diagram that we have seen earlier. So you can see the students actually request the fitness class, and then manager receives it. Once the manager receives this, manager checks whether the fitness class, whether there will be availability. So then depend on that, the manager will notify the students and then ask for the payment. And then student has to make the payment. This interaction happened between student and manager, and then manager, register students in the system, right? So you can see that the whole process of the function we can represent within the sequence diagram. Some more examples, for example, in this one actually represent the shopping cart. So in this case, you can also see a customer, shopping cart, order, and the item. So the external item. And the person, the customer is the one who actually create the shopping cart, then only the vertical bar appears. And during the shopping cart, you can get the total of the orders. And to calculate the total of the orders, you have to get the price of each item. So for each item, you request the price, and then you will get the item price. And as a interaction within the order, it will calculate the total. And once you will calculate the total, it'll actually send back the total to the shopping cart, right? So you can see that the dynamic interaction is captured here, right? The next one is state transition diagram. So in state transition diagrams, we can say different states, for example, bank accounts, right? So when you open a bank account, it's a new account or current account. And then after sometimes, if you like not using them, it goes to a different state. So if you want to represent the change of the state of different objects, we can use state transition diagrams. So in state transition diagrams, we represent what we call the status. And usually you have rounded rectangles with the state name, right? And then we are representing a small circle to start the initialization of the state. And then it will point towards these objects. So usually when you read from left to right, so the line direction describe the action of the event, goes from transition to one state to another. Right, let me show you an example for this one. Now, for example, this actually, the state transition diagram will show you different states of opening an account. Now, for example, when you open an account, this is the start. It will be a new account, right? You just created it. Once you make some deposit, it changes the state from new to active or existing. Then sometimes that go into frozen states. Sometimes when you're not using it, or sometimes if the government want to hold, so that can go to frozen states, right? And once you have assets released, then they can go back to active states. Now there are one other state. If you close the account, this closing the account can be done in two ways. Customer can close the account. So that means you go to a different state like closed. And the bank can also close, right? Both actually comes here. And finally, this will indicate the end. Another one is what we call activity diagram. This one, activity diagrams, we have what we call the horizontal flow charts, and we can represent all the actions and events, right? In activity diagram, you can show the order as well, and you can also identify the outcomes, right? Now, here is an activity diagram. This is the start, and the requirement is customer needs some cash. So you will have here the customer insert the ATM card, and then, okay, card is accepted. Then you enter the PIN. Then if the PIN is accepted, the customer can request cash, right? And once you this one, you can have two arrows here. What is the two arrows? If you request cash, if the sufficient funds available, you take one path. And if you do not have sufficient funding, then you take the other path. Now let's assume you have sufficient funds, then ATM adjusts the balance and you get the cash. But if you do not have sufficient fund, this should be notified to the customer. So as you can see here in activity diagram, you can show everything, right? To represent how the action and events occur. Right. So that's what we missed from the last time, right? So we have looked at a couple of diagrams. We start with user case diagrams, the class diagrams, right? Then we have sequence diagrams, state transition diagrams, and so on. So in this group work, what I want you to do as a group, again, like we did in previous cases, you have to first propose information systems, which improves the object of your organization. And once you identify this, then identify the possible actors. In university system, remember, there are some actors like students, the staff, administrative officers, and so on, and assistant registrars. So you can identify like what are the possible use cases and actors for your proposed system. The first task I want you to do is come up with a user case diagram. So identify a couple of user cases, identify the actors, and then you can identify the interactions. Now, once you identify one particular user case, then you can create the class diagram. So one particular user case, you have to create a class diagram. Like for example, student registration, we can have a class diagram where we represent the students, the staff, the administration. In our case, you can have the UGC, for example, as another, case here. And finally, I want to select one particular user case. I want you to create a sequence diagram, how exactly this will happen. Now, for example, if in the university, if you have like course registration, the students actually register for the courses, and then if that goes to a manager or assistant registrar who should accept this, and then you can borrow in case this one. Right. You can take, for example, in that particular case, let's say you have the students and then the staff, we can the assistant registrar, for example, student can request for the registration. And then you check the documentation, and then you can say, okay, accept or the reject, right? Okay, now to create, okay, before we move on, any questions on object-oriented analysis and design? I think I have already shared the slide. Can one of you confirm? Have you got this set of slide last time?
Doctor, we didn't receive it, Doctor.
Okay, right.
This one.
So let me first share that, because you need it to start the work. So I'm sharing the document via the WhatsApp group. Confirm me whether you have received this one. Right. So I have just sent you, there are 56 pages which we describe the different object-oriented, representations, the tools and the techniques. We were discussing different diagrams for this. Yes, were you able to get the note downloaded?
Yeah, we have received, Doctor. Thank you.
Yeah. So now let me create the groups for today's session. So we have 21. So I'm going to create 7, where you will have 3 for in each group. Right before you joining, make sure that I have to leave the system by 3 o'clock. So I hope you can work among the group members. So I have all your registration numbers, except one person with iPhone. Can you confirm your registration? Right. Anyways, please join the breakout rooms, but make a note. I'll be closing by 3 o'clock, and I hope that you can work together to come up with the answer for the group work 5.
Excuse me, doctor.
Shifani, which group you were in?
Group 7, doctor. I got disconnected.
Okay. Yeah.
I
Anyway, I have to close as well. So make sure you connect with them, and
right.
then
Thank you.
Kavisha, the Kavisha. Shifani, you can join the